Alright, so yesterday I was looking a bit into wave function collapse, and the reason for that is once the game compiles, so I can show you, is so we can generate these tiles inside of our chunks and then use wave function collapse to decide whether tiles should contain trees, rocks, land or water. And right now I removed all the trees and stuff, so we can start using this new method. And yeah, like wave function collapse, I think the first time I saw it was on a coding train video, and yeah, like I watched like a while back, so I didn't remember quite well how to do it, but like, you know, in the end figured it out. And I have this example which we can go through, because it was really painful to get it in a Rust format, but because the algorithm is extremely simple, right? So you have a bunch of cells or tiles the same way I have in my map, right? So let's imagine this is a chunk, right? So let's imagine this is a chunk split into small tiles. I'll just do the drawing like this because, you know, whatever. And let's say that each tile can have a number of different like options. So like, for example, 4 options. Each tile has 4 options. Let's imagine that. And there are some rules, maybe we have water tile can only be next to land tiles or something like that, or we have like deep water which needs to be next to water and cannot be next to land, you know. So what that means is that if we choose a random tile and we choose the value for it, so let's say this becomes land, then we know that we can subtract some of the options for the neighbors, and maybe even for the neighbors' neighbors, right? And whatever, like propagate this new observation, right? So we collapsed these tiles or these cells options, right? Or I guess wave. And now all the neighbors have different number of options. So I guess in the coding train video they had like these kind of shapes, you know, the T's, and if you put this T here, you can connect the T up with plus, for example, or with another T like this, but you cannot place one like this because it doesn't connect. So yeah, like if you have this kind of tiles, then maybe you could have more interesting rules. But for us, honestly, I think like not completely sure what the rules are gonna be for the terrain. Maybe we need a lot more tiles to do that, but in the example that I did, so yeah, we can go through the algorithm itself, right? So we have this wave which is gonna be like a tray, so like an interface, and it represents each cell in our grid or each tile in our chunk. So we need a function that checks if it's collapsed. This is just you know, for checks if it's collapsed, whatever, doesn't really matter. Then we have this entropy function, which honestly I was trying to make it like this, but I don't know why Rust is such a dummy language. It doesn't want that for some reason. The compiler complains, like, you know, it's here I try to be Haskell like, but yeah, I don't know, like Rust doesn't really manage to be Haskell-like, although it feels Haskell-like in some weird way, but yeah, we wouldn't want to do that, so I just went with I32 for entropy, and entropy is just this number, how many options do we have, and yeah. Then we have this collapse function, which updates the current wave, like it sets its collapsed value to true, and it uses a random number, and it returns that value. So wave is gonna have a containing type, so it's like an option, the sum thing, and it returns what's inside when you do collapse. And then we have propagate, which the purpose of this function is to update, but not really update because it's not mutable. It's gonna be, we take in a self, like a wave, and a list of waves, and we want to apply, we want to check all the options for this cell based on all of these cells. So we want to validate the options basically, and we return a new one. I wanted to do it like this with mutable and not return anything, but it wouldn't work, so I just went with a simple way like this, and yeah. And then we have our implementation for the wave function collapse, and yeah, this one, I mean, the entire thing was pretty, like, up until line 70 was really annoying to do, so yeah. But yeah, like wave function collapse, how does it work basically? We have the new function which just takes in a list of waves, so a list of this kind of stuff, like structures that implement the wave trait basically. Then we have, I guess the interesting function is probably gonna be the collapse function. I mean, also propagate. I propagate, what it's gonna do, it's gonna iterate all of the cells in our waves, and it's gonna apply propagate on them. And this is where I wasn't able to use the mutable thing. I was trying to do itermute on waves, and then have a wave be mutable, but the compiler was complaining that I cannot use self.waves in here. I guess that makes sense, because when you propagate, you actually want to create a new, I guess a new, how do you call it, a new vector. You don't want to change it in place. Like, thing is that propagate needs to create a new vector. It cannot work by changing the old one, because we would have partial updates, and we don't want that on our waves. We want to have the previous step, and based on the previous step only compute the new step. So makes sense, but yeah, it would be nice to be able to, I mean, probably could do that, make a copy of self waves and then be able to use a mutable here, but I don't know. This works too. It's fine. And then here, this I guess is the main part of the algorithm, although I mean the main part is up there, but we implemented iterator for this structure, so we can iterate over all the things in it. I guess we'll need to see what iterator does. Then we sort by some index, and we just return the contained value. So how does the next function work in iterator? Well, we have to get our waves, right? We add an index, and we add the index just so we know which cell do we modify, like because we need to sort the array, and if we sort the array we'll lose the order, but we need to keep the original order. After we sort, I guess after we take the waves, we filter out all of the collapsed waves because we don't care about them. They are already collapsed, so what's the point in trying to collapse them? Then we sort by entropy in ascending order, so we want to choose the minimum one. I guess using minimum here would also work, but no, it makes more sense to me to sort them and do it. I mean, it's the same, if you think about it, it's the same big O complexity, because I mean, probably it's not, because if you try to find the minimum it's just O of n, right? But yeah, whatever, could use minimum. I guess there is a minimum, or is it not? It's min by, right? But no, could use that, min by key or something. I guess min by key just replaces that, right? And it should still work, but let's check afterwards if that still works. Anyway, so we choose the minimum entropy element, and I guess if there are multiple elements, sort by key says that it keeps is stable, does not reorder equal elements. So it's like merge sort, if I remember correctly. I don't remember if merge sort, I think merge sort is like that, right? And quick sort is like not stable. Anyway, we take the minimum entropy wave and we just call collapse on it. I guess this thing can go here, but it's like we collapse the wave, right? So the wave is gonna modify, so it's gonna update its inner state, and it's also gonna return the containing thing. So it's gonna return the t here, and also the index, because we need the index for ordering, right? And otherwise we just return none because we finished the iterator. After we manage to get the containing value, we call to propagate. So yeah, and this was also the painful part. So it wouldn't work to call propagate inside of here, because we already says it, like the compiler says, we already borrowed this as mutable and we cannot borrow it twice for some reason. And I guess if you do it afterwards it works, like even though it's the same thing. So pretty strange how this is not an error, but if you put it here it is. But maybe it's like you are inside of this thing, which could be a for loop, so in that case maybe it can be weird, but whatever, who cares? Like in the end I managed to trick, like saying trick the compiler is, I don't think is the right way to think about it. Like the compiler is trying to help you basically, but anyway, and at the end just return the container, like the container value, right? So let's see like an example of implementing this all of these traits and stuff, because originally I started out without, like, just by hard coding everything, and then I was like, okay, let's do some Rust magic, see how how you are not necessarily how you are supposed to do it, but how like complicated stuff would work. But yeah, so was hard coding stuff, and initially I was like, okay, what can you put here, like first, second, but I was like I would like some symbols that can actually go together, and I was thinking, okay, let's do a 1D version because I'm too lazy to do 2D. So I was looking at my keyboard and I was like, okay, let's do C, because you know, C. And then X makes sense. It can, you know, in a drawing you can have, let me show you how I was thinking. So you can have C, and then you can have, well, like an X like this, so you know, makes sense. And then I was like, okay, after an X there can be another X, and but now I need a character that can come after the X, and I was like, oh, maybe D, right? And just because all these keys are right next to each other on the keyboard, I was like looking at the keyboard and I was, oh, and even before D we can have, you know, like this and like this, so you know, we can create some kind of shape with these letters. And yeah, that's the rules here, like how you can use. So to be honest, I don't remember what left options was. Like, if this is on the left, these are the values you can have on the right, right? So that's what it means. All right, so if you have a D, you can only have a C next to a D. And the right options is the other way around. If you have a C, you can have a D on the other side. So D and then C. Yeah, I mean, anyway, doesn't really matter. So here I had to implement wave for my thing, right, for this structure. And I guess this is the interesting part, right? So is collapsed is just gonna return if we have any value in our container. And I guess, where is my wave? My wave is this. So it has an index, the list of options, and an optional kind, right? So I guess entropy just returns the number of options. Then collapse is gonna choose a random option from the list of options. Is gonna set the collapsed value to that thing, and it's just gonna set the options to a vec with a single element. And I mean, this is just for simplicity. And then inside of propagate, this was a bit more complicated. If it's collapsed, then we don't do anything, and otherwise we go through all the waves in here. And I guess we have to check the neighbors, and we have the left neighbor and the right neighbor. Then I guess for this we just, you know, take the options, we check them. I mean, it's really hard coded, but you get the idea. It's like you know, we take the options from the left side, then we intersect them with options from the left side or the right side, and in the end, you know, we just set those options. And collapse is going to be none. Pretty sure about that, because we just checked that here. So that's how we update the wave. I mean, I don't know if this can be extracted in the trait itself, but looks like it could, you know, like maybe have a function that generates the neighbors and do all of this somehow there. But yeah, so yeah, I mean, in the end I just, you know, created a lot of waves. Now what's, I think, interesting about this approach is that you can create waves with random, like any options that you want here, and then when you pass them, you know, to the wave function collapse structure, then you have customized waves. You don't have to start with all waves have the same values. You can do whatever values you want, but I just wanted to start with like anything. Then, you know, took a random seed and just called collapse on that thing. And yeah, actually, like what this CXD thing turned into was Dix. Just drawing Dix. Bit a shame, but I don't know how the hell I got to Dix. Like, it's so weird. But yeah, I mean, it just went to dicks, literally. I was like, wait, let me just do, you know, 2 char just to display them. And I was like, wait a second, if I do 8 instead of C and equal instead of X, we have fucking dicks. And I mean, that's, yeah, what can I say? 12-year-old brain. But I mean, you know, we could have done it something different, but I mean, we still get like random shapes, which is pretty, I mean, these are pretty sad, not gonna lie, but on average it's pretty big. I mean, what can I say? So the goal for today is, if we go back to our game, is, oh, you know, I said I wanted to check something, if it works by using min by, right? So instead of all of this, min by key, will this work? I guess it does. So, you know, you can use this. Not that important though. So I have copy pasted all of this. Let's just, you know, I have copy pasted the trait and the implementations and stuff. So now the only thing we have to do in the game is to implement the wave trait on our cell. And yeah, we just need to say is collapsed, do the entropy thing, collapse and propagate. So that's the only thing, right? Okay. And I was thinking maybe, you know, propagate can be, like, probably it will be, I'll try to do that later, like try to make it have its implementation done by me, because it's pretty, like, it's the same every time in a weird way. Like, it's an iterator over the waves, so you just need getting the list of neighbors, more or less. But yeah, I mean, at the same time, this allows you to, if you have weird, I guess, yeah, no, let's leave it like this, because if you have like rules like these, probably it makes more sense to use it like, I don't know. Let's just leave it like this for now. So, you know, we have this stuff, so we just need to implement wave for our tiles. So question is, so tile kind is gonna be the tile kind, right? So we need the wave, so like something like tile wave. Can we do that? Let's do it down here. So struct tile wave, and let's follow the example from that I made. So we need this tile wave, right? Let's just copy this thing. So something like this is going to have options, tile kind, something like this, right? Well, we need clone and debug, but do we really need them? I think clone is needed for some stuff, but we'll see, like, if we actually need it. Anyway, Okay, so I would say we need this new function as well. And what's interesting is, let's say that for the moment we generate them completely randomly, but we'll want here to add the noise value, F32, right? So that's gonna be more interesting. And based on that we generate the initial options. So that's why I would still use the Perlin noise to get the initial options for the tiles. And I mean, even after the initial options we can still do some checks using Perlin noise. But yeah, tile kind here, you know, would be cool to have some other kind of thing somehow, but yeah, I mean, you know, whatever, tile kind and water, land, forest and stone. Land, tile kind, forest, tile kind, stone. And this can be a none. Okay, and then we have to actually implement wave. Alright, so impl wave for tile wave. Let's get that, and yeah. So the inner type obviously is tile kind, I guess. Yeah, tile kind. Right, we need a tile kind, and now it would be interesting. So I guess this is the same. The same thing. Entropy again is probably the same. Like we just return the number of options. Then collapse is gonna be also the same, which is interesting, right? We just need, why is that? Yeah, well, that's interesting because we have iter tools. I mean, maybe it's in random or something. Maybe it's in random. Oh, so we need the clone for this thing, right? To be able to call clone, because I did, like, it's pretty weird here. So that means tile kind, I don't remember why is it hash and EQ. It only needs to be clone, right? It needs to be clone, I think, for now. Anyway, so, and now we need to implement the hardest thing, which is actually propagate. But as I said, let's do it randomly at first, like completely random. So let's say we don't have any rules. So what that means, what does that mean then? So if we try to propagate and we are collapsed, then we just return a clone. of self. Otherwise we need to create a new one, and I think this is why I need to clone on the wave itself, right? Because we make a copy here. So I think tile wave needs to be clone, right? Cloneable. Okay, so this is the main part, right? Like that's why I'm saying anyway, so in here we need to do some black magic. So I guess we need to check the up, down, left and right neighbors and get the options from them. So how can we easily do that? I guess the easiest way is to have let mutable options is equal to self dot options, maybe dot clone or something. And now we should go through those neighbors and remove options as we go, right? So yeah, that's gonna be interesting. So I think the thing is we have index of our tile. I mean, no, honestly this is really stupid. I could have just indexed the array, but let's not talk about it. Because yeah, that was like just experimental code, so we don't care about it. Okay, so yeah, as I'm saying is we can generate the up neighbor, so we can maybe do something like waves dot, can I do get? Yeah, I can. That's pretty cool. So we want to get the, well, I guess index is not really enough. We might want 2D index, so index could be a uvec2, right? uvec2 actually, because it's 2D. So inside of the waves, this is also going to be interesting. Because we have the 2D index, but waves is a one-dimensional array and we don't know the width and height. So yeah, that's tricky. It's a bit tricky. Because sure, we can pass here the size, but that's lame. We can take the length and like square root it, say that we only accept squares, and you know, that makes sense. I guess the implementation is up to whoever does propagate, so we might as well keep the size inside of the tile wave, like grid size. Though that feels weird. But okay, let's go to wave. Would it make more sense to, like, this is, you know, the list of waves, deal with it however you want, basically. Like, you know, it can be 3D, 4D, like, doesn't matter. Because we can just iterate them in order. So it's one thing, and yeah, like propagate, you know, doesn't make sense to take in the size. Like let's just see. Let's put the size here. Why not? UVec2. Why not? So let's have the total size. So it's gonna be like UVec, and this is gonna be like the size of the grid. So we know it when we create it. So pretty self-explanatory. Well, I guess the size can be just use 32 because we have a square. So we have the size, like size of the, like the side of the square. So in here we can do stuff like self dot index, let's say we take the y, multiply by size, and we add x. So this is the location of our current cell. To get the up, like the cell from above, we have to do -1 here, I think. -1. I'm wondering what this wants. Oh, I guess size is equal to self.size, right? But what does this want? Tile wave, what? It needs to be indexed by usize. I mean, I guess so. Looks like this works. The only issue is that this subtraction, don't think it's gonna work. Like if y is gonna be 0, this won't work, right? Can I have an easy fix? Don't think so. But anyway, let's think about it afterwards. So if let sum up is equal to this thing, then it's going to be similar to this. So we take the options that are available on up, and we keep only them inside of our options. So something like options is equal to options dot filter, wait, iter dot filter, and something like option. So this is the option that we currently have, and we need to check if up dot options contains O. That's what we need. And then collect vec. Right, what? Partial AQ. So we need partial AQ and probably AQ, right? Or what? That what? So, oh, intuiter, right? Can I do intuiter? Why not? So we get back this thing. So we have to do the same thing but for all cases. And now, yeah, this is what's interesting. I guess if this thing is greater than 0 and, right, ew. Shut show. Damn it. So how can we, you know, I like having a separate function. They're like, come on, let's just, so we cannot do that here. We have to have here. So fn up, like up neighbor should take in a self and probably the waves. Well, I guess let's call it neighbor. Neighbors, am I right? And here should be, one sec, should be self, right? A list of selves. And this is gonna return back a vec of self, right? So we can have something like this. Yeah. Probably let ns is gonna be an empty vec, right? It should be mutable, obviously. So to check this thing, I guess we need another if statement. If it's greater than 0, we do something like this, maybe. Do we need to clone it? Guess so. Anyway, so we could do the same thing for down, for example. So if this is smaller than self.size, then we can do +1, and this is gonna be down, and with the same thing for left and right. So this is gonna be left, and for left we have to do -1 here, and this is gonna be right. Hopefully. And here we do +1. you know, really ugly function. Let's leave it there. So as I said, in our tile map, it won't matter if it's up, down, left or right. It only matters like how we connect them. I guess, I mean, I don't know, maybe in the future, I don't know, who knows, we'll see. Let neighbors is gonna be self neighbors, and we pass in waves. Okay, so now we can do for neighbor, wait, yeah, in neighbors. Okay, I like that. Can do that like this. We need to do this kind of check. Neighbor, right? So for each neighbor, we just say we take the old options and we just intersect them with the options from the neighbor, and yeah, hopefully this is gonna work. So yeah, I think it looks like we implemented everything that we needed here, right? So what would be next? I guess actually trying to create the tiles, right? So I think we already create tile coordinates and stuff, so we have this tile wave, and we have tile kind. So yeah, so probably, so in chunk, I commented out some of the stuff that was doing terrain generation previously. I wanted to see when we create the tiles. So here we create the tiles, I think. Weird. I was pretty sure that we create tiles somewhere here. We don't? That's strange. So where do I use tile coordinates and stuff? For example, tile. Oh, here. In terrain itself. Oh, so when I spawn chunks, I also spawn the children. Okay. Fair enough. With tiles per chunk. So this is gonna be the size. Okay, we have the size. And the index is gonna be tile coordinate. Okay, makes sense to me. So I guess the only other thing is if we spawn only one is gonna be easy, but we have to do it for each chunk. So maybe it's gonna be easier to implement that on chunk itself. Well, not necessarily. So yeah. So there is this way of being able to query. For example, we query the parent, and then we can query all the children. So we can query the chunk, and then all the children are gonna be tiles. So these are the tiles that we need to create. And the parent, right? So we have the chunk, and we can have the children of the chunk. So in this kind of system, we can call to wave function collapse. So let's try to write that system. Let's do it here. So we're gonna have wave function collapse. It's gonna take in something like q parent. For the query for the parent, what stuff do we need? I think we need with chunk, right? That's the main thing. We need chunk. But what else do we need from chunk? Chunk coordinates? I don't know. Chunk noise map? Probably, but not right now. No. We might need chunk noise map, but in the future, because we want to generate the tiles after we do the noise generation. So query chunks, right? But I don't know what else do I need. I can say chunk coord, but I don't think we need chunk coordinates unless we take the noise, but even for noise we just have the noise. So I mean just the children, and the children to okay, and here would be tiles. So for this one I need tile and tile coordinate, or I guess tile coordinate with tile. Right, so now if we iterate the parent, so the chunks, we are gonna get the tiles inside of them, or I guess children. And let's do it like this. So this is gonna be children, right? So that way we get the child, and then we can actually just get a tile that we need, like this. Okay, perfect. So this would be tile is gonna be q tiles get. I think this is gonna be a result, but I think we can expect that it's gonna work. Honestly, what the fuck? Let's do what the fuck. I think that's, I don't see how can actually be an error. Like, can it be an error though? because we iterate. Yeah, it would be incredibly weird. Like somehow have a child that does not exist. Like, yeah, but this would be tile coordinates. And as you can see here, first thing that we need is tile coordinates. And obviously the size, but the size we can get from the config. So let's say terrain config source is going to be this thing, right? So terrain config contains the size, tiles per chunk. So we have the index in this thing, and we also have the size. So we can easily just create tile waves. So let's actually take this thing. Let waves is gonna be this dot map. So this is gonna be child, and here we can say stuff like tile wave. Well, I mean, probably it's easier to just do something like this, and then maybe I mean not really return. I like to use return to indicate actually returning stuff. So we do new, and tile has tile coordinate tile dot 0 probably, but I think it's nicer to just dereference it, and then terrain config dot tiles per chunk, right, and then collect vec. What the hell? So in Twitter, excuse me, what? Okay, can I just say that it's a reference? Yeah. So we have a vec of tile waves, and if you remember from wave, this thing takes in, like wave function collapse takes in a vec of waves. Who would have guessed? So let wfc new waves also takes in the seed. I don't know about the seed, but yeah, I actually don't know about the seed. Because this is going to generate the same thing everywhere. Oh no. But who cares, right? For the moment, let's see. Okay, that's interesting. So tile wave needs debug. Why? Really? Oh my god, the errors are starting to pour in. Okay, we don't need debug. I think I was printing something for some reason, and yeah. Whoops. So this gives us the wave function collapse thing. So next up is let kinds is wfc dot collapse. So now this is a vec of tile kind, and what's gonna be interesting is creating a component here probably with deref, right? Pub. So we don't know if it's gonna be public or not. Tile kind. No, we can make this one a component, but tile kind. But you know, it's ugly that it's the same name, and I don't want to do tile kind component. It's ugly. Tile kind component. It's gonna have a tile kind. Right. I mean, could make this one a component. Sure, let's do that. Let's do this on a component because you know, Bevy allows that, so why not? So now we have a list of components. Pretty interesting, if you'd ask me. So okay, that means that we need some more stuff. For example, commands, so that we can insert stuff. And we also need the entity here to be able to, this is the, wait, what? Oh, so we need stuff like that. Parentheses, really? Cool. So now we need another for loop over the children. So children.iterate. Then we do a for each child like this. Like it's the same thing. Let I guess, you know, this could be named tile covered. And now we have tile, and we don't care about this, is equal to this exact same thing. Okay, and we need to say something like commands.entity tile.insert. We need to insert the kind, but for that we need to zip kinds, right? And inside of this for each we'll actually have kind too. So that should be everything. Maybe here but doesn't matter for this instance. So add systems. So if we check chunk systems, okay, we also have, like, let's copy paste this. So the only system that we need is wave function collapse. Yeah. But come on, just fix the error. Okay, so now we have tile kind. Let's see if this thing runs. I mean, you know, we don't show anything. I guess this will run on every frame, so we have to somehow make it not run on every frame. Right. So it has tile kind, which is pretty cool. But it's gonna run on each frame because we don't have any without, and a good one is gonna be without tile kind. So what? Oh, yeah, like this. And the only thing is, I think this is gonna trigger what the fuck, so let's see. This might trigger what the fucks. It didn't, what the fuck? Oh, yeah, it did. So that's what I was saying, it should probably trigger what the fucks because now we have all the chunks but not all the children. Okay, so how can we maybe do that? So one way would probably be to do a filter map. The other one would be to take the parents and do a group. And this is like an interesting question because it would be interesting to have like a query, like some kind of SQL syntax for these queries, because basically that's what they are, right? But they are more like in game style. So yeah, we just need to ignore the chunks that have the children already generated. So should we take the parent here and then do a grouping, or should we just get here, do something like as sum? Can we do sum? I think this no method sum. Really? I was pretty sure that Rust result to option. Rust result to option. Okay, what? Oh, okay. Oh my god, I just fucking close it. So instead of sum, we can use OK. And this is gonna be interesting. Oh, I don't remember the syntax. Let's wait for the LSP to finish. So right, like this returns a sum. Can I don't remember how you would do that. Oh yeah, like this. So filter map it, which takes in like that, and I need to sum it. Okay, so now question is, this can be empty, so this doesn't do anything. Let's I mean, this is still gonna be called every time. So maybe it makes sense to do it the other way around. and have queue tiles be first and have the parent, and then we group them by the chunk. I feel like that's a bit weird. Do we have like a group by or something inside of iterator? So chill group by. Oh shit, we do. So it might make more sense. Let's do it like this for now. I would say this doesn't matter. Because we can have tile and this. So this can be if let some like this. This can be like this. Right. Do it like that. So now it should only run once for each individual tile. Right. I mean, we don't see anything. Let's do some printing maybe. Println. No, I should print the waves. And we'll see that this is gonna run. Oh my god. Let's do kinds. Really? The fuck? Huh. So this should probably show us the like empty list at some point, obviously, but you know what? Let's do like if kind.len is greater than 0, that's when we print. Oh, I forgot, Rust, you need to put squiggly braces. Oh shit, everything the fuck. What the fuck? Ain't no way. Well, that's that. Ladies and gentlemen, that's cooked. Okay, that's really cooked. I guess this, like everything here should be fine. So no, maybe the seed is at fault, so that's why I'm saying the seed is gonna make it the same for every chunk, and that's not good. We should have an RNG resource. But you know, I don't get why is the same. Oh, I know why it's the same thing. Because that's how we did it here. We didn't check for allowed options. We just went with everything. So I guess if we want true random, then we don't have to do anything here. This is gonna give us true randomness, like this thing, right? So this is gonna make all of them random, which is nice. But I still think this should be done, maybe, no, add to do it with parent and group by. I think it's gonna be a bit more efficient, like, I don't know, we'll see. I mean, it's the same thing. It's still 2 for loops, so it's the same thing. But yeah, here we need to create those rules. So if we take a look at this thing, we had options, right? So let's see. Oh no, here. Function rules, right? So self is gonna be a self reference or something, and we need to return a vec of self, right? A vec self, something like this. So we match self, and let's fill in the arms. No, did what? Really? You want me to write that myself? That's cooked. Well, I guess it should be done in my wave kind, not here. So in this one, let's do impl tile kind. Really though? Yeah. So we have rules, and for example, let's say if we have water, we can only have tile kind, water tile kind land. Then if we have land, we can have all of them. Right. Then, whoops. For this one, if we have a forest, we can have like this and like this. I don't know, something like this. Oh, I forgot about the vec. Right. So inside of this, what we actually needed to do was take all the options and then do the check. So we need to take, 1 second, need to take the options, iterate them. Okay, flatten. Okay, so options, iter, map option o dot rules. I guess flat map makes sense. Flat map, and that should do it. Oh, contains the O from the outside. So this should still give us randomness, pretty random at least. Quite random, right? I guess water, but it's the same thing everywhere because of us using the seed, and I start to not like that. So let's rather have, but you know, I'll do that myself. Let me add the to do for myself here. To do, use have an RNG variable instead of seed itself. Like we should have similar to wave, for example, see, which has an RNG here. We should probably have an RNG, but that's for later. Anyway, okay, I'm a bit lost. Okay, so this star wave. Should we try to do it with a group, or should we just continue? Let's continue with this. So noise map data. Right, we need the noise map data. Well, not noise map data. In fact, we need chunk noise map. The chunk. Oh, pub super. Right, we need a chunk noise map. So this is gonna give us this and the noise map. Oh, and I need to reference. So noise map. Interesting, right? The next thing is passing here the noise for the options, some kind of noise F32, right? I mean, it's F64, but F64 for the noise. All right, so here would be maybe interesting to do noise map. And we should pass in something like the terrain coordinates. And some kind of sizes. Like I'd say chunk size and tiles per chunk, but oh, that's just the config. So I was thinking like sample, and then we pass in the tile coordinates and terrain config or something like this, but we don't have yet sample on a noise map. I mean, even sample could just take like a random value from the noise map, but I want to do the average. Honestly, I think I want to do the average. So let's go to chunk and let's do some impl noise map data. Oh, it wants okay, let's call it average, although that would have been interesting. I don't know. Average. Pub super average, and here we need some kind of, I think it's UVEC, yeah. So we need UVec and terrain coordinates. So coord is gonna be UVec2 and terrain config, and it needs to return F64. Okay. I think I need to dereference it, right? What? It doesn't have data. Oh, it needs a self, right? It needs a self. Self. The fuck? Oh, we also need to dereference this one twice. I guess only once, and and then reference it. That's so cool. I'll fast. Okay. So now we have the stuff that we need, right? Terrain config. We have the size. We have everything. So let's try to get the data now. So let's first let's get just the top left corner because it's gonna be easy. Right, so top left corner, right? How can we do that? So size is the size of the map. Coordinates is the coordinates, and we also have chunk size and tiles per chunk. So we can get something like let tile size is gonna be terrain config dot chunk size divided by tiles per chunk, and this is the tile size. But there's a but. The noise map is scaled, so we also need, wait, what, before that let me just the noise map is scaled, so size is not equal to chunk size, so we actually need to multiply this entire thing with size divided by chunk size. And finally, what that means, so if we just ignore the dick from the screen, so we have chunk size, right? Chunks CS divided by TPS, tiles per chunk, TPC, I guess. If we multiply this thing, as I said, with size, so CZ size divided by chunk size, so we get the scale. So this is the scale and this is the tile size. We can reduce this and we get size divided by TPC. So it's actually self dot size divided by, and now we get the tile size like this. Isn't this amazing? So actually we just need tiles per chunk here. Right, we just need tiles per chunk. Would be maybe more nice to depend only on tiles per chunk, which is a U32, rather than so in tile. Man, I really hate that it's becoming tiles per chunk. So complicated, like I need to see the example working, you know. I need to tingle the tingles. So we have tile size. What's next? Tile size. Well, figuring out where we need to look actually. So coordinate multiplied with tile size, like it give us the center, right? Let's think about it. 0 0. Not really. Yeah, not really. It's gonna be the top left corner. So top left is gonna be tile size multiplied with coordinates. So this is the top left, right? And let bottom right tile size multiplied with coordinate plus 1. This is the bottom right. I forgot about the equal. But yeah, we have top left, bottom right. Next. What's next is actually doing the ranges. So for top left dot, well, I guess this would be the column, so let's call it column in top left dot x, which is the first value, right? Dot x, and we go up to bottom right dot x, right? Then for row, and I guess we can call this y, x and y. Honestly, I hate it. So like this is the column, because you know it's the column, and then the row top left dot y up to bottom right dot y, and the not equal, so up to. Let index is gonna be row times self dot size dot y, I mean they are the same, doesn't matter, plus column. So this is the index, this is the index. So let mutable sum is gonna be 0. Can I actually do it better, like avoid division by 0, like this? So let's iter. We don't have iter, right? Well, we have into iter, but do we have Cartesian product? Let's think. Do we need Cartesian product? I think we do. And then we map it. We map, and here we have column, damn it, column and row. Jesus. Column and row. So we get the index and we return self map index, like this. Well, I mean index. Yeah, I mean u size doesn't matter. Average would be nice, but we have some. Okay, so let value is gonna be this, so we collect into a vec. I think we need to collect. I guess, you know, the easiest way is someone. Yeah, some. Just wanted to be like, if it's empty it should return 0. That's someone. No. Well, how can we do that? So we do the sum. We need to divide by the length, but that's like map the value v divided by values.len. The fuck? Something happened. Values dot length. I mean, the fuck. Okay. So okay, or, but this is for errors. How can we say like Rust sum or value option? What the fuck? So map still returns an option. Interestingly enough. Let x is, I just want to see what the fuck x is. So x is an option. So x is option. Oh, why is it unknown? Rust map option. Map or. Oh, map or. Okay. Dude. The fuck? So values. Dude, come on. F64. Do I really need this thing? Like, it's so weird that I need that. Yeah, what the fuck? Whatever. So this returns the average, or 0 in case it's empty. Alright. So now we initialize this thing by using noise. So let's go on tile kind and have another thing. From noise F64 should return back of self. So can we do like match noise and then have comparisons? That would be interesting. But like Rust match int, let's say. Oh nice, if d is more than, okay, so n, if n is smaller than 0.0, then we only want tile kind water, right? And on the other case, let's take this one. Let's be like n, if n is smaller than 0.5, we put everything. And on the else case, like anything else, we put only, well, I mean, let's do it like, otherwise we put this, like, we'll see. Alright, so and now, sure, this annoys me, let's remove that. And now we can do here options is style kind from noise, pass in the noise. Cool. Right, so let's see if this does anything interesting. So, I mean, I see, but I actually want to see them. So what that means is that here when we do colors, so where's the debug? See, like here I did it in the other way, but for tiles, okay, that's why I knew about the tile thingy. So the color, let's have only in debug mode we need that, so color. Okay, so match self. So if it's water, it's color blue. If it's land, it's gonna be color green, let's say. Let's do brown. Do we maybe have like, I don't know. Dude, we have fucking salmon color. Where is it? I saw it. Okay, lost it. And we don't have brown. Beige. Let's use beige. come on, we have beige and we don't have brown. That's color, and this one could be gray. So we need tile kind, and here tile kind to color. I think this should just color everything. Pretty nice. I mean, this is almost, holy shit. We're pretty close, dude. Holy shit. Oh, beige, it sucks. But see, we have like different kind of, no, I'll do, I don't know what color to do for fucking trees. I thought beige is gonna look good, but it doesn't. Let's use fuchsia. Bro, I cannot believe we don't have brown. Oh, maroon, that's maroon 5. Right. That's another way of saying brown, I guess. So pretty cool. Now the issue is that we use that seed, but I'll have to deal with that myself. And yeah, you know, it looks decent. Maybe I'll add more tiles, have a lot more tiles and a lot more rules for these tiles, because we only have 4 tiles and that's not gonna cut it. But I think this should do it in a way. I mean, let's no longer print the kinds because we have debug mode active and we can see using colors. But yeah, like we'll need a lot more tile kinds, but you know, I'll come back with more tile kinds at some point. Let's do a small commit oh, feature some stuff with tiles. No, I was just working on another branch, so I can just squash everything, so it doesn't matter what names I put in commits. So yeah, you know, I'll do this. But now how about trying to actually add back the objects, I guess. But how will that work though? Because let's see. So inside of chunk we had all of this cool stuff, but this was for the Perlin noise, or I guess noise, that we used with the forest. So in forest generate, for example, we just did whirly stuff, this stuff, and then we, you know, butchered the noise map, and then we do pass on this sampler. Alright, so we should do something like this, but this only happens for certain kind of tiles, so that's also another one. But let's just copy paste this for the moment. So inside of tile, well, I'm not gonna do it right in this function. I think I'm gonna create a new function, maybe one for Q tiles. So actually generating the disk distribution and objects and stuff should be done. Let's say, so in this one it was called forest generate. Let's call it tile forest, tile generate forest, right? So we have the commands, we need that, we need the tiles, and we also need tile kind now. So this is gonna be called if we have tile kind, but we'll also need another indicator for generating the thing. So what could that be? I guess like rendered. You know, let me first copy this stuff over just to have it, because it's, so it has Q tiles, forest points. We need a seed, obviously, whatever. Forest tree radius, but let's say it's gonna be 1 for now. Chunk size, oh shit, it's equal to tile size. So we divide chunk size using tren config tiles per chunk. So this is the actual size, F32, and the K, let's say, is gonna be 30. Right, so we need this. Then here we were doing some filtering, which that would also make sense to still do filtering, but not right now. I just want to get tree data going. So here we just created tree data. Tree data here should be like tile coordinates, tren config. Oh my god. We'll have to see about this. But yeah, we don't have the noise and stuff, so might as well have just the P, and that's it. Right. Okay, I don't need this one. So forest points. Right. Okay, I need a for loop. So for an identity for tile, tile coord, tile kind in Q tiles. Okay, something like this. And can I say here tile kind forest, for example? Or I guess I need to borrow it here, right? The fuck? And this thing doesn't matter. Why do I need to borrow it? I guess I need to call iter on it. Oh, but this is really cool. the fact that we can filter like this. I think we can filter. Anyway. So here we can collect vec, right? So we have a vec of vec2. Now we just need to figure out the tile size. Right, like this. So we have the tile size, and when we get the point back, I mean we already did this, but now it's the point plus the tile coordinate, and the tile coordinate needs to be multiplied by tile size, and we need to also subtract half of the tile size. Just because this will move it to 0, 0, and this offsets it. So yeah. Irrefutable pattern. Well, your mom. Well, I guess, you know, the easiest other way is filter. And we have don't care, kind, and kind is equal to forest, and here we don't care. Yep. We won. So kind is freaking reference. Oh, okay, anyway. Bruh, really? Okay, let's unborrow it. Another one. Weird. Okay, so this gives us the forest points. After we were getting the forest points though, so like where this was used, so forest points, we were just spawning shit, right? So for whatever commands spawn, spawn. Okay. Now obviously these are gonna go in their own separate plugins or something. And here we should have like without tile forest or something, or I don't know. No, and this is also gonna be in that. So, and I mean, if I already said it's gonna be in that, let's do it here. So, derive component tile forest. So we do whatever, and here we say something like commands entity tile insert tile forest. right? So we forested it or whatever. So now we need a resource position. We don't have noise though. It is what it is. Resource position, resource piece, and 3 resource. So we need more stuff. I think we need these things. So let's add them here. We don't need this. Resource piece, what? Let's not do resource piece. So resource position and 3 resource. Let's remove rock. Okay, tile generate forest. Let's add it in the freaking plugin. So, but yeah, as I said, it's gonna be part of a different plugin. So tile generate forest, right? So it's gonna generate forests, and we need the other thing that we commented out. So the render thing for trees, and this is going to be in also another system. So we need just that. Obviously we need game assets. I don't know about the chunk config though. So handle. So we need a resource position with 3 resource and without resource renderer. Okay, so we are gonna do, I don't need a noise. Let's just not make a scene. You know what I mean? So scene bundle, we do this. And I don't think we need a CPU config. Okay. I mean, can I handle 3 render? Okay. I mean, will it run? That's the important question. Well, I mean, obviously I'm expecting it to crash instantly, so holy shit. I mean, we got something. We got something quite interesting. I guess part of the problem is where we place these bitches. Okay, so let's see when maybe I did something stupid here or something, I don't know. So we take the tile coordinate, which is, oh, I think we also need because tile coordinate is local, so we are gonna have the following thing: a position from the disk sampler between, I don't know, 0 and 4 if I remember correctly. Then we add 4 or whatever 0 to tile coordinate, which is gonna be inside of the chunk, multiplied with tile size minus tile size divided by 2. So this is gonna keep it in the chunk coordinates. And now we need to add a chunk coordinate. So I think I had a function world or something like toWorld, tile coordinate to world position. So it's on tile coordinate. Oh, it's right here. So it's p plus 2 world position, right? So we need the chunk coordinate, chunk size, and tile size. Well. size, but we also need a parent, so let's take, so let's say Q tiles. I'm pretty sure I had something with parent around here. Let's take this. Oh, it's in debug, okay. Pretty cool, not gonna lie. So we need a parent. So chunk coordinate. Chunk coordinate with chunk, obviously. And this thing was chunk noise map, okay. So here let's say parent. And now we can say something like chunk q chunks dot get parent, right? And that should always work. So let me just do something like this. Should always have a parent. Like doesn't make sense. Okay, and here we don't care about this as well. So now it complains that world position so this thing is gonna take the tile coordinate, so the center of it. Ah, I'm wrong. It should have been, I mean, it was fine. I just, whoa, what the fuck? It's the, that, come on. Let me just copy it. So it's P plus, let's think, P plus this thing so this gives us the chunk, the point inside of the chunk, and this gives us the global position. So let's think about it. But this is like the center. So if we add this with this, it's almost correct. We just have to subtract terrain score config chunk size divided by 2 and then add all of this. But the issue is this thing is vec3, so let's do xz on it. I think this should probably work. I mean, if it's first try, then I'm the god coder. Holy shit, it's almost oh, but no, like it looks like complete trash, I'm gonna be honest, but I mean it's still better than what we had. So it's a bit shifted or what? Oh my god, how long do you think it's gonna take us? Like 1 hour to figure out this math thing? So how it looks like it's shifted in the bottom right direction or what? No, it's not. Like all of this stuff should be here or something. Let me do it again. Oh no, it's over. Something's wrong. Oh no, wait, yeah, green is fine. So I have to look for brown. Okay, fine. Let's think about it. So we have P, which is the position inside of the disk, right? So that's position inside of the disk. There's like a small offset between 0 and 4. Then we have, let's take it from the back. So we have tile coordinate to world position. This works for sure. If we pass in tile coordinate here, we should get back the center of the tile in world position. So in world position we get back the center of the tile. That's fine. So if we just do this thing, it should put everything in the center of each tile. Let's debug it. So this should be now in the center of each tile. So if it's brown, it should have that in the tree in the center, right? I mean, by itself this looks pretty cool. Wait, the tiles are pretty small though, but doesn't matter. Right, so this is brown, it has a tree inside. That's what matters. I mean, it looks pretty cool. Yeah, I think this was a good decision, honestly. Okay, afterwards, what would happen if we add P to this thing? What would happen if we add P? I think, but it's hard to see that. I need a place where it's, I'm pretty sure how it's gonna work. I need a better way to debug stuff then. Like, it looks like it goes in that direction or what? Because this looks brown and stuff looks like it goes like that. Oh, I see why. See, like, we have to shift this to this corner. So let's subtract tile size by 2. And that should be enough, right? Because now it's between 0 and tile size, we want to make it between -half and half. Okay, let's see again here. Oh, I think I have to add it. Weird, I have to add it, right? Okay, I have to add it. I guess X comes towards us or some stupid thing like that. But yeah, like now it looks fine. But you know, the trees are kind of shit because it's like they have the same seed pretty much. Oh no, what? Why are these outside? For some reason something's still looking sus. Like, I think I did a whoopsie doopsie somewhere. Because yeah, they don't match with the tiles. Let's do everything white. Let's do everything white except the forest, which is gonna be blue, because I want to be able to see better. Okay, so now we have everything's white except I literally said, but yeah, see, like here, but I said blue. What the fuck? Why is it green? The fuck? We have some green shit. Oh, I was like, what the actual fuck? Okay. Something's a bit scuffed. I mean, okay, if tile kind is equal to tile kind, no, forest, that's when we do this. Otherwise we don't do anything, because borrow my PP, dude, come on. Something's a bit scuffed. Okay, so now we see better what the issue is. I think indeed we need to subtract, but you know, where is it? Where is it? Here. Pretty sure we need to do minus. It doesn't make sense to do plus. Okay, now it looks better. Yeah, now it looks better. So now it actually matches, which is pretty neat. And yeah, we have like trees now. Although, I mean, we already had trees. They look pretty scuffed at the moment, but you know, with a bit of improvements, probably they look better. Like, one improvement, of course, is actually going back to doing all the colors correctly and doing the minus here. So that was the issue. And the other thing is, when we spawn stuff, let's make it smaller, 0.5 on the scale. So yeah, I'll have to refactor that, move it into like trees or something, because yeah, I mean, it looks okay. Maybe, you know, the map doesn't really look that great because of the white there, but and all the patches are the same. Like, if you take a look, they look exactly the same. So adding more randomness in that is the next thing. But other than that, I'm fine with this stuff. Obviously it looks like it probably runs something like something's not good somewhere. But you know, that's for future me to figure out how to do. So yeah, like the plan, like for me for the next couple of days, is add more tiles, tile kinds, I guess. The next thing here, I think this one's, well, it doesn't matter. The plugin, like this part to do. This should be in a separate plugin, I think. Right, like a plugin for doing forest. Then here I would do it the other way around. Maybe it's gonna be more efficient, I don't know. Then we have this part which to do move out. And this is like tile wave, which should stay here. It's implementation for tile. It's fine. So yeah, I guess now if we add more rules in our tiles, we should not have to change anything here. It should just work with this. So I don't think we need to ever look at this code again, which I'm extremely happy about. But I think we need to move out the generate forest, and that should be all. And then do the rocks exactly the same way. So maybe have like a resources file where I put everything related to resources generation. And yeah, I think rest of this stuff is fine. I don't think we need to do, like, I was thinking maybe doing multi-threading for something, but I don't know what, so let's not do it. Like maybe for wave function collapse, but I don't know. I also want to, as I said, pass in here a seed. Instead of a seed, pass in the RNG directly, like store the RNG somehow in a resource. So yeah. Even though it's not really needed, because like it's still fine like this. Because my guess is that based on the noise and everything, the RNG, it's fine. Let's not worry about passing in RNG. It's fine using seed, I think. So yeah, like if you use seed, it's easier to parallelize, but I think it's still fine. Now hopefully by the end we'll have, if you pass in a seed, it's going to generate the same world. That's what I'm hoping for. And yeah, I think we should use seed for these things to achieve that, even though it's going to look a bit less random at points, but I think it's better. So yeah, like here in this thing, where's the pause on this sampler, I think we are gonna need a noise, like we did I think here, or something for the rules. So we might need a noise map, right? Yeah, we might need a noise map because you saw that sometimes there are trees in the water. So even though the tile is let's say forest tile, it shouldn't really be, or maybe I'll add some rules that you cannot have forest tile next to water, but maybe we also need to think about this and get the neighbors in the corners, not only up and down, maybe also in the corners we need to take the neighbors. So let me add a comment here to do think if we need to take also the corners as neighbors. Oh, that could be something. But yeah, I think maybe one last thing that I want to check is inside of generate forest without tile forest. Oh, I added it. Okay. But like if I do println and I say because it looks a bit slow-ish, so without resource renderer, with 3 resource. So let's see, I mean, because it looks like it's slow, like it feels slower than before, which, so it generates once, that's good. That's decent. And if I do it here with 3, do we generate it only once? I think, yeah, it should happen like that. Yeah, but I don't really get why it's slowish. Like even when we zoom in, it's still slow. Maybe it's because of the gizmos or something. So let's run without debug, and without debug we shouldn't see those lines, but it's still slow. Maybe it's because of how many things we spawn, so that's why I want to have better rules. But I mean, I'm pretty happy with the new system, doing it like this instead of yeah, but it's pretty laggy though. But yeah, it's cooler. So yeah, maybe I'll think about, maybe we also need to check the corners so we don't yeah, but I think, yeah, that should be all for today, and we'll see in the next one, so see you.